See Lindelof videos, AP Calculus, trapezoidal rule with a piecewise function. We're asked to find the definite integral of f of x dx from 0 to pi, given that f of x is equal to sine of x over x for x is greater than 0, and f of x is equal to 1 if x is equal to 0. The first thing I'm going to do is just really quickly remind you, because this is what it really comes down to, about this approximation that we're allowed to use. And this is an approximation, so please be careful about using a equal sign. This is 2a. I'm sorry, b minus a over 2n, right, times f of x sub 0, the initial value, plus f of x sub 1, plus dot 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 f of x, and this is 2 here, and this is 2 here. But remember, on the last one, on the last approximation, we don't use that. We just use plus f of x sub n. So the pattern is 1, 2, 2, 2, 2, 2, 2, 2, 2, 2, 1 at the end. So all I'm going to do is just build this thing a little bit, and then I'm going to follow my rules. First thing I'm going to do is get my b minus a over 2n. Well, b minus a in this case is pi minus 0 over 2 times n. N is 4, so 2 times 4 is 8, gives me pi 8. I also need my change in x, so I'm going to come up with my change in x, and my change in x is just b minus a over the number of intervals, which is pi over intervals is 4, is pi fourths. So see what this looks like. All I'm going to do is set this up exactly the way we said we were going to do it. So I'm going to say my approximation is pi eighths times f of 0. Well, f of 0 is 1, right? And it's f of 0 because that's the lower limit. The lower limit is that 0 right there. So that's just 1 plus 2 times, remember, we're starting at 0 and we're incrementing each time. We're increasing each time by pi fourths. So we get sine pi fourths over pi fourths. All right? And pi fourths plus another pi fourths is 2 pi fourths, otherwise known. So here's the 2 from the pattern. So this 2 is this one and this one. So I have sine of 2 pi fourths, which of course I know is pi halves, but I just want you to see where I got it. I'm just incrementing pi halves over pi halves. Remember, I'm going all the way out to pi, so I'm just making sure when to stop. So the next one is plus, and that's this 2 again, sine of 3 pi fourths over 3 pi fourths, right? Over 3 pi fourths, plus sine of 4 pi fourths, which is just pi, right, over pi. Isn't that right? So look what we did here. We started at 0, and 0 the value was 1. So we evaluated that. The value is 1 because of the piecewise function. So we evaluated when x was 0, the function height was 1. And then from there, though, I didn't go from x. This is not x is 1. This is the f of height. This is f of 0. From 0, I went to pi fourths. So pi fourths over pi fourths. Then I went 2 pi fourths, which is pi halves, 3 pi fourths, 4 pi fourths. Done. So you're asking me, what's the answer? I don't know what the answer is. I have this approximation here that's 1.836 is my approximation. Let me tell you that while I expect you to get this numerical answer, as important as anything is that you show to your AP reader that you can set that problem up. So I hope this was helpful. If you have any questions or comments, let me know. And if you have